There's this one star that should have exploded 300 years ago, but it didn't. And it's not even the weirdest thing that's happened to it. The name WR is actually short for Wolf-Rayet, which describes a class of very luminous stars that are in the later stages of stellar life. And if you go back 300 years in time, its location in the sky should have been empty. You see, there were two competing astronomical catalogs in Europe. Instead, he suggested that it was just a comet passing in front of a star and blocking some of its light. But China noted that comets aren't that bright, and this star was shining like a true nova. Then the star faded away, leaving only a tiny nebula in its place. Its brightness increased significantly, and its spectral lines shifted towards the blue end of the visible light spectrum. And that meant that the star was rapidly spinning. All signs pointed to WR 1248 being the remnant of that exploded star from 300 years ago. One belonged to the Danish astronomer Tycho Brahe, who had been a contemporary of the much more famous Johannes Kepler. He estimated it at 3.5 magnitudes, which means that it was shining at around 2.5 times the brightness of the full moon. The next sighting didn't come until 1666, when the English astronomer John Flamsteed reported that the star was brighter than when Custis had seen it. By 1672, it had grown fainter again, and by 1680, it was gone. But humans don't tend to perceive things in terms of brightness. We tend to perceive things in terms of apparent brightness, how bright something looks relative to everything else. And so we tend to judge the brightness of stars in a similar way. It's available on various platforms, and the link will be in the description below. As we mentioned before, in 2010, the star suddenly became much brighter, and that suggests that it's in the final stages of stellar life. Fast forward to now, and we can observe that stellar wind impacting our heliosphere and causing a beautiful green glow that stretches from the Sun to Pluto and beyond. When that process begins, the outer layers of the star expand greatly, and it transitions from a blue giant to a red hypergiant. Eventually, all that expansion will cause the star to lose enough mass that the core will collapse and begin fusing even heavier elements. Let's assume that the historical records are accurate, which is always a fair assumption to start with. If the star had 300 years worth of stellar wind blowing towards us, and it was shining 2.5 times brighter than the full moon, it should have exploded 300 years ago. Scientists hope that studying the star as it continues to evolve will help them better understand the mechanism behind these explosive deaths. After all, 300 years is a very long time in astronomy. Astronomers think that the most likely culprit here is the way that the brightness was recorded. A team of astronomers has discovered what they believe to be the first zombie star. Zombie stars are theoretical objects that should have exploded as supernova long ago, but somehow are still kicking. Click here to learn more. That wouldn't be unprecedented. There's another star known as M101, which is in a different galaxy, and it also went supernova around 300 years ago. See, there are two ways to measure a star's luminosity. There's the absolute scale, which is essentially how much light the star is emitting, and the apparent scale, which is how bright the star appears from our vantage point on Earth. It would be like trying to find the remains of a building in a city that had been completely redeveloped 3 centuries prior. You see, the star that appeared 300 years ago wasn't nearly as bright as WR 1248 is now. But that doesn't mean it was actually more luminous. It could just mean that the sky was darker because the moon was new and therefore smaller and less bright. It's not too hard to imagine that the star would appear brighter against a darker background. And the record of the star's brightness seems to be a bit, well, screwy. That is, there could be nothing left to show where the structure once stood. In other words, we are currently flying through a stellar wind that was blasted off the surface of this star 300 years ago. Kepler used Brahe's catalog of stars when he developed his laws of planetary motion. Meanwhile, the German astronomer Christoph Scheiner worked for the Jesuit order and had his own catalog of stars. The two had become professional rivals. So when word got out that each of them had recorded the appearance of a new star, they both took it as a chance to prove themselves right. That's because 300 years ago, astronomers saw a supernova explosion at that very same spot. He described it as having a faint, hazy appearance, not as bright as a comet, but still visible. It stayed roughly the same brightness for several years. They recorded the event as a new star in the constellation Sagittarius, a star that shone brightly for a few months and then disappeared. They are extremely hot, extremely bright, and emit strong stellar winds. WR 1248 is particularly massive with around 17 to 20 solar masses, and it's pulsing with around 10 million solar luminosities. To put that in perspective, our Sun is a relatively small and relatively dim star. So when something is 17 times more massive than our Sun and 10 million times brighter, you know it's packing some serious wattage. Join us as we explore what exactly is going on with this peculiar star, where it is, how we know how old it is, and why it's such an important clue in understanding the life cycle of stars. We are, of course, talking about a star known as WR 1248. This is a Wolf-Rayet star in the constellation Sagittarius. It also shouldn't exist. You see, WR 1248 is about 4,000 light-years from Earth. In fact, it was quite the kerfuffle at the time. Brahe claimed that it could unpossibly be a new star because he'd already charted the heavens and made careful note of every single star. Astronomers today believe that this nebula is the remnant of the supernova explosion that created the stellar wind that's still speeding towards us today. But for a long time, astronomers weren't sure if WR 1248 was really the star that had exploded back then. But between 2010 and 2013, the star underwent a dramatic change. But as recently as 2019, scientists have been re-examining the historical records and realized that there may be a problem. The earliest record of the star comes from the year 1604, when German astronomer David Fabricius noticed the star while observing the skies for comets. Then in 1611, the English astronomer Edmund Custis observed the same star and gave its brightness a numerical value. And that poses something of a problem. So either the star isn't the one that exploded, or the historical records are wrong. Stars get dimmer the further away they are. And there's a straightforward formula to calculate how dim a star appears based on its distance. When Flamsteed saw the star in 1666, it might have been shining brighter than when Custis saw it 6 years earlier. And that means that there's a good chance that the star did explode 300 years ago, and it just didn't appear any brighter than it does now. If you want to learn more about what's going on with this star and others like it, check out our podcast, See Show Space. Now, while astronomers work out the details of this star's past, they're also paying attention to its future. At this point, the star has exhausted most of the hydrogen in its core, and it's begun to fuse helium into carbon. And when it does that, it'll probably explode in a spectacular supernova. And while that's going on, we here on Earth will enjoy watching the dying embers of that explosion reach us and illuminate our night sky with an eerie green glow. Speaking of strange stars, have you ever heard of a zombie star?